Welcome to the DIY Honda Garage channel. The DTC P0713 indicates a fault related to the CVT, Continuously Variable Transmission Fluid Temperature Sensor, which has detected an open circuit issue. This issue does not stem from mechanical failures in the transmission, but from electrical circuit problems. The CVT Fluid Temperature Sensor plays a critical role in ensuring that the transmission operates within the correct thermal range, helping to enhance performance and prevent overheating. When this code is triggered, it indicates that the sensor is not providing the expected signal level, leading to potential operational problems. The HDS, Honda Diagnostic System, is utilized for diagnosis and should be used to check the signal readings and thresholds. It is essential to address this issue promptly to maintain optimal transmission function. The error description for DTC P0713 highlights a failure concerning the CVT Fluid Temperature Sensor, which is responsible for monitoring the fluid temperature in the transmission. This sensor's readings are crucial for effective transmission operation and longevity. It is located at the transmission fluid area, typically integrated into the solenoid wire harness, which connects to various components within the CVT system. A failure in this sensor suggests that it is either not transmitting data correctly due to an open circuit or encountering issues within its electrical connection. Remember, this DTC is purely electrical. Mechanical transmission faults are not the cause and must be verified through testing with the HDS tool. Several possible causes can lead to the activation of DTC P0713, primarily focusing on electrical issues. An open circuit in the sensor indicates a break in the wiring or connection that prevents a signal from being transmitted correctly. Additionally, poor connections or loose terminals can result in intermittent signals or failures when the vehicle is in operation, which may not be consistently detectable at all times. Lastly, a faulty transmission control module, or TCM, could also contribute to this issue by not processing the sensor's input correctly. To identify the root cause, each of these components must be carefully inspected and tested. When facing DTC P0713, several symptoms may manifest, indicating issues with the CVT fluid temperature sensor. The most evident symptom is the activation of the check engine light in the dashboard, alerting the driver to a technical problem. Furthermore, the transmission may experience overheating, potentially leading to long-term damage if not addressed. Unusual behavior during transmission operation, such as slipping or shifting problems, may also occur, which can affect drivability and safety. These symptoms are crucial to monitor, as they can suggest other underlying issues associated with the transmission's functionality. The first troubleshooting step involves problem verification. Start by switching the vehicle to the on mode without starting the engine. This allows the HDS to read parameters from the vehicle's onboard computer. Check the voltage reading from the CVT Fluid Temperature Sensor, which should exceed 4.93 volts under standard conditions. If the conditions match this threshold, it confirms the failure can be replicated, leading you to proceed further in the diagnostics. However, if the current condition does not match, it indicates an intermittent failure. So it becomes essential to check for poor connections and loose terminals between the temperature sensor and the TCM. In this step, focus on determining the possible failure area. Start by turning the vehicle to the off mode to ensure safety. Then, disconnect the 8P connector from the solenoid wire harness to isolate the sensor circuit for testing. Use a jumper wire to connect terminal A of this connector to a body ground, setting up for a voltage check. Turn the vehicle back to on mode while monitoring the HDS for the CVTF sensor voltage value. which should now read less than 0.07 volts, indicating that the sensor circuit is open. If this condition is met, it suggests that further diagnostics on the sensor itself should be performed in the next step. The third troubleshooting step requires another check of the transmission fluid temperature sensor. Turn the vehicle back to the off mode before removing the jumper wire. Now, establish a new connection by joining terminal A of the solenoid wire harness with terminal B from the same harness, incorporating the previously identified terminals. Once connected, turn the vehicle to the on mode and again monitor the sensor voltage through the HDS. If it reads less than 0.07 volts, this indicates a faulty transmission fluid temperature sensor, leading to the recommendation of replacing the solenoid wire harness A. If the readings show normal functionality, the next step focuses on checking for wiring issues. The final troubleshooting step involves checking the wiring continuity on the TATF line. Start again by ensuring the vehicle is turned off. Disconnect the 50P connector from the TCM to access the wiring between the sensor and the control module. The focus here is to check for continuity between two test points: terminal number 7 on the solenoid wire harness and terminal number 33 on the TCM. If continuity is confirmed, the TATF wire is functioning correctly, and it suggests checking for any authorized service information related to the DTC or symptoms. However, if continuity fails, it indicates an open circuit, requiring repair of the wiring connecting solenoid wire harness A to the TCM. Once repairs are completed based on the previous troubleshooting steps, it is crucial to verify that the repairs were successful. First, check the vehicle's onboard diagnostics for any reoccurrence of DTC P0713. If the code does not reappear, proceed to conduct a test drive under various conditions to ensure that the transmission is responding normally and that no erratic behavior is observed. You should monitor the transmission fluid temperature during the drive using the HDS to validate that it is within acceptable limits. Success at this stage indicates that the sensor and associated wiring have been effectively repaired. If issues persist, further investigation may be required. Preventive maintenance plays a vital role in ensuring that the CVT fluid temperature sensor continues to operate effectively and can help prevent future issues. It is advisable to perform regular inspections of the sensor wiring connections to detect any wear or damage that might lead to circuit failures. Additionally, ensuring that all electrical connections are secure can minimize the risk of intermittent faults affecting vehicle performance. Using OEM, original equipment manufacturer, or high-quality replacement parts is crucial whenever repairs are made to maintain system integrity. By adhering to a proactive maintenance routine, you can help preserve the transmission's health and ensure the longevity of the vehicle. In conclusion, DTC P0713 demonstrates specific issues related to the CVT fluid temperature sensor, with a focus on electrical problems rather than mechanical failures. The steps highlighted throughout this troubleshooting guide are essential for effectively diagnosing and addressing the underlying causes of this DTC. Appropriately verifying the fault, replacing faulty components, and ensuring continuity in the electrical connections are critical to resolving the issue. Furthermore, regular maintenance practices can significantly reduce the likelihood of reoccurrence and enhance vehicle durability. By understanding and responding to this diagnostic trouble code effectively, vehicle owners can maintain optimal functionality and performance of their Honda Civics transmission system. Please like and subscribe to the channel. See you next time.